Hello everyone and welcome to today's Dev Club. It's amazing to host you here all at Coolbet. And as agreed, my primary job is to put you to sleep, so my colleagues will have all the pizzas to themselves. My name is Umut Pazarbasi. I am the lead database administrator here at Coolbet. For the last 4 years, I've been here, and next month, actually 4 days, I will be celebrating my 4th year here. So there were some great questions on the polls, and I will try to answer those and try not to leave anything hidden here. And I would like to, okay, let's have this talk as well. While I was putting my talk, I wanted to name it "So You Want to Be a DBA." That's the reason for that is, let me first see how many DBAs here. 2. Did I see someone there? 2.5. Okay, let's count me as 3 as well. Okay, so 3. Any developers working with DBAs in their company? All right. So that's the reason this talk is named "So You Want to Be a DBA," because you are already a DBA in your company, in your daily lives. Yeah. So you are designing your own schemas, creating your tables, your functions, your procedures, and so you are a DBA. But then let's skip this part and maybe not skip forward, but go a little backward. Like, let's remember how you come to this state, shall we? So we all start with this while we're working for production environments or for our side hobby projects. We create a feature. Yeah, we're developing a new feature, we create a new table, slap a quick index on top of it, and then we say, okay, there's something in my mind, but yeah, I don't have time to continue. Let's think about it later. Okay? And then that later arrives usually at a 4 a.m. call. Anyone? And then, yeah, I see some, yeah, some heads, nods. And then we stop and we say okay, so it was working fine. What happened there? Well, first of all, I want everyone to understand or know that databases are living organisms. It's like people, it's like animal. And when you feed it something, it's either good or bad, but then it gets fatter and fatter. If you don't take care of it, if you don't work on it, if you don't care for it, then it gets sloppy, lazy, because it doesn't want to do anything. Yeah? So we need to take care of it and not just hope for the best. So, and then not find ourselves in this situation. I guess we all remember this movie. Yeah? So, all right. I'm not gonna give any prescriptions here today. All right. There is no one size fits all. Yeah, here is your red pill, and this will make you better. Guarantee here. But I want to create or expand your vision. Okay. I want to create an awareness of the things that we can do to improve our systems, or let's break the ice between developers and DBAs. So let's join me in this journey, and let's go a little bit to the start. Where we start? We start with making that decision with our architecture. So again, this is not saying that monolith architecture is, it's great. No. Or it's not saying that microservices is great. No. This is where we create this illusion, destroy this illusion, and be aware of what we are trading off between them. So you see, we have on the left hand side, we have this giant source of truth that we keep all of our data in this giant database, and everything is ACID protected with known constraints. The data is protected within one database. And on the other side of the equation, that we have this microservices architecture. So things start beautifully at first. Yeah, we have pretty light, loosely connected applications, few API calls here and there, and then it's good. Life is good, yeah? But what we are trading here, can you tell me? Anyone?
Network performance.
Yeah, we have network performance, but we don't care about network performance. We will leave it to the infra team. Yeah, it's, and of course, here we can say it was network. Yeah? So, with this, yes, we are introducing more complexity, of course, but sometimes we forget about this, that we are distributing our data. So now we are opening up this problem, that eventual consistency that we don't see with monolith architecture. Of course, it's not to say that monolith means everything is like in one giant database. Doesn't mean that. But you see, we just using this or that? It doesn't matter. It's just being aware of our architecture. Yeah. So with this, we are now exposing ourselves to the eventual consistency. What's that eventual consistency? Anyone knows? So
the data needs to be consistent, as it says, eventually, so it's not immediately available. But eventually it will get there.
Yes, great. Thank you for that. Yes, the data is not eventually, it's not right away available for the other application, But that's not the only case. But what if the other application, maybe it's not even, the data will not be even shipped to the other application or the database. So there are many cases now we are introducing by separating, distributing this data. So, okay. So I guess we all agree with this problem that we have. And then we can talk about what we are using to distribute this data. So we have different engines to store our data. And mostly, like we know, is RDBMS. We have Relational Database Management Systems, classic. We have it for centuries, you can say, I guess. Anyone knows PostgreSQL? It is coming from Berkeley research with Ingress database, hence the name Postgres. So it's the post-ingress database. So, okay, I haven't written the name here, but also we have MongoDB and some other databases that we know as not only SQL databases. So these database engines are totally different from each other. They serve different purposes. We can talk about a little bit more with this. So on the left hand side you see Mongo database, a document store database, we can say. It's classified as NoSQL database. But also we need to be careful here that there are many other NoSQL databases, such as Cassandra, which is a white column database, which is good with key value pairs, which is good with inserts, heavy writes. And Mongo here is a JSON-based, BSON-based document store, which is good with reads. And on the other hand, we have PostgreSQL, for example, to represent the RDBMS, because RDBMS engines, more or less, they have the same stuff, although there are some different cases with them, and we will see them too. So no matter what the database engine we have, even if it is an RDBMS versus an RDBMS, they have different architectural DNAs, and we need to know those so that we will develop with that in mind. So here you see, this is like doing or taking your truck, for example, to take your family to a Sunday drive, if you use MongoDB. And the other one is taking your scooter to haul your home to another apartment, for example. So we need to use the correct tools for correct job. And here we have two of my favorite database engines. One is the Enterprise King Oracle databases. Anyone knows Oracle Corporation? Great. So I dedicated my life to Oracle databases and Oracle technologies. I was an Oracle University instructor for many years, and then I slowly switched to the open source and community-driven databases. But it is still one of my favorite databases, and it's number one. So we have these two RDBMS engines working in the background. What do you think if we start updating an identical table on the same, on its different architectures. Well, same architecture, different DNAs. What do you think? What will happen? We are updating the whole table.
Oracle is faster.
Sorry?
Oracle probably is faster.
Yeah,
Depends.
could be, we can say that, okay. But the difference here shines if you really know what's going on in the background. So again, identical tables, and the session starts updating the whole table. Oracle has a very genius architecture running in the background, which is the undo, which keeps every previous change, every previous record of this table in that database, and then Oracle updates in place of these records. So while it is changing the record, it keeps the old value in the undo table space. And Postgres falls a little bit short on there. So what happens is when you update the identical table, you will have this result. The Postgres will double the size. Well, there are some cases that is not valid for this case, but let's keep it in this way, because we all know we like to heavily index our tables, and then we like to do heavy updates on every transaction after every transaction. So let's keep it like this, all right? So what happens here is then you need to utilize the vacuuming and statistics heavily for PostgreSQL to keep up with the load. You see how two same architecture but different DNAs behave here. And what do you expect here if you are selecting from this database? It basically needs to read all the changes because it updates the records in line. So what it means that it needs to read all these old changes as well while trying to bring you the up-to-date data. But on the Oracle side, it's not gonna do that. So it's like you are basically sacrificing your performance here. More IOPS, more memory usage, because it needs to pull all the data to the buffer. So you see, even with these two, we need to be careful. So similar to Oracle, MySQL or MariaDB has a similar way of having an undo mechanism compared to PostgreSQL. But then PostgreSQL has physical replication, MySQL doesn't have, it uses logical replication. So you see how things are going there. Yeah? Well, here we need to be careful about the engine that we are using and use the correct engine, correct tool for the correct job. Since we talked about the general architecture, monolith, microservices, or distributed monolith, so we also need to talk about the protective perimeter around our databases. So because there is not much thing on the database side to do when you are hammering with, for example, tens of thousands of sessions, there is only a finite number of resources, hardware resources that can be utilized at a time. So if you have a 16-core CPU, you should expect 16 active sessions utilizing these cores at a time, more or less. This means that we need to protect our databases. Just like how you are protecting your applications, you are using, I don't know, load balancers, F5, or I don't know, any other load balancer in front of your application, or some enterprise versions stuff there. And similar to those, we also use some load balancers and poolers or cache mechanisms. What's a cache mechanism? We have Redis for cache. Anyone knows? Okay, Redis? Few? Okay, oh, yeah, getting better. All right. Anyone knows what's a pooler? I guess you are also using some poolers on your applications to connect to the databases, keep your sessions up, manage your sessions, manage your transactions. Yep. And these two lovely applications, Kafka and RabbitMQ. Anyone? Kafka? Rabbit? Ah, now we are talking. I see. Now we are talking. All right. We'll get to that point as well. Okay. So, I understand this is kind of boring that, you want to use a pooler on the database. Okay. Be my guest. Use it. What am I going to do with it? Solve your job. So, we don't want to hammer the database and crash it and then your applications will suffer. So, we use poolers and we use Redis. Mostly it's suggested by developers actually, not for DBAs, not by DBAs, but developers, because they want to have this instant result from this cache mechanism. And since you don't want to run the same query over and over and over, like thousands of times per second, per minute on a database, and what it might makes. It needs to be parsed, syntax and semantics checks needs to be done, and then compiled and then run, and then the result gets back to you. But if you cache it, you will just get the answer right away from the Redis. Yep. So if we can think of these of our shock absorbers, and of course the Kafka and Rabbit is not database shock absorbers. They are basically headaches for databases. But let's talk about it. Let's put things visually so we will get there. You see our beautiful monolith architecture from that previous slide. We put some cache or pooler in front of the database. And let's say we were having some extreme connection issues like logon storms on the database side, just like the application, it happens. So we were having that, and then we decided to, protect our database. Let's put a pooler in front of the database. Now, what happened here? We added one more attack surface. Yeah? And did we actually fix the issue? Yes, kind of. But we introduced another point of failure. We added another complexity. I'm not saying these are bad, these are necessities, like we need to have them. But just for the sake of being aware of our environment, what's happening around us, and for what architecture we are developing, this is how it looks like. And then on the first slide, we had these two applications connecting each other with an API. Now we said that, this API call is costing too much. It's pretty, the latency is getting worse every day. So what we did? We introduced this new architecture. We are now extracting the data, putting it in Kafka, for example, and then using another consumer to consume that data and put it in the database of another application. Now what we did, we solved one problem and we introduced a future problem. You see, these are, yes, I understand, these kind of things are necessary to have a good performative applications or solving some problems. But just so we are aware of what we are creating for the future. Also, you are seeing that now you are moving data to another medium, which means you are basically reading the same data on the database engine because there is another process running there, and then there is some extraction being happening on that data, and then that data is now duplicated on another storage layer. And then you are reading the data again. You see, you insert one, read one, do some operation on it, have some CPU resources, waste it, burn it, and then write it, read it, maybe do some operation on that, insert, and then read it again. You see how many times for just one operation we are introducing more and more. All right, let's move on to our future. So we talked about the database engine, the differences between NoSQL, RDBMS, even NoSQL versus NoSQL. And there are a few things that I can suggest you to bring to your own applications or databases when you're doing. Some of them might seem like old school, for example, using database functions, procedures. Why? These introduces new cases that we need to test. Yes? Instead of testing your application, only the application code, now you need to test the database code. But what it brings you? It brings maybe a security protection from SQL injection. It brings you performance improvements. If you have a complex business logic running a query, then you offload it to the database, which now is already parsed and compiled and stored in the database inside, and then you just need to call it. If you are doing this over and over like lots of times, then this will bring you more performance. This doesn't mean that put everything on the database. No. And please don't touch our databases. No, it's jokes aside, and these are a good ways for you to bring something different, experience with it, and try it. These, for example, prepared statements, if you are just changing the where condition, if you're like looking for an ID, getting data by ID, why not send the same SQL query to the database over and over and try to parse it, compile it every time? You can use prepared statements. Just keep it in your mind. You don't need to do these kind of things, but just know you have more options to bring to the table. Next time when you are thinking about something, you will have these in your pocket. All right. And another topic to bring to the table as well. Most of the time when we find ourselves in this, it was working fine situation, it's why? Because the tables are getting larger and larger, and then the database engine is trying so hard to grab this data. But you can introduce partitioning from the start if you know, or if you expect these kind of transactions. Because what makes difference from developers from DBAs? Developers know the business logic. You are the ones that are developing it. You have the power on that sense. You know it, and we don't know. We will never know until it's too late, because then we will try to, let's extinguish the fire. And then you will see, we try to check this table, that table, and you will get annoyed by us. We will get annoyed by you. Why they did this? Why they didn't tell us? And then you will say, why they're not checking the metrics? No, it's not easy to track each and every query all the time. But you have the power because you know what gets inside the database and what gets outside the database, and what applications are connecting, what calculations are being done, and what will be done in the future. So join our forces and bring these to the improvements plan. Also, you can just use default partitions, by the way, with PostgreSQL, Oracle, or any database, which then gives you an advantage that when the time comes that you can just slice a partition on those tables without any downtime. But if you don't, then you need to switch that table with a partition table. Do we know what the partition is? I'm assuming that we all know partitions.
No.
No. Yeah, I know. Thanks. So partitions are a way that we distribute data within a table. You can distribute the data based on intervals, date, time, based on lists. For example, you have, let's say, a table about locations, and you can have this table divided by states, countries, or you can have a definite number of partitions, and then you can distribute the data by hash, or better, you can have best of both worlds, a composite partition. So you can have a hash partition, for example, which makes the partitions the data try to equally distribute on those partitions, which is good for write-heavy applications. And then when you want to archive, for example, then you can detach one of the old partitions and send it to an archival database, or just get rid of it. You don't need that data. Okay, delete it. You don't need to change anything else. And it's, for example, one of the good and bad ways that Postgres uses partition indexes. So each partition actually is a table in Postgres mind. So each table has its own indexes. Contrary to Oracle, for example, Oracle can have partitioned indexes and also global indexes, which brings sometimes good, sometimes bad performance, but also it gives you the ability to use a single column primary key with global indexes. But then with Postgres, you need to think about your primary key because the partition key needs to be within that primary index, primary key. All right, another boring topic. So, utilize the database engine that we talk, these functions, these prepared statements. You can use that, you can give it a try. Of course, it's hard to do it if you are developing some cross-compatible applications. Some you need to also support MySQL, Oracle, PostgreSQL, because sometimes there is this kind of need that you are developing compatible, like cross-compatible applications, but if you have a dedicated database engine that you are using, don't take it as a interchangeable thing. So about the partitions, that's okay, and then we come to this. Mostly this interests DBAs, but I see we have many DBAs here. So that we need to protect our database, the data, correct? So we need to have redundancy, which means more performance for developers, for our application. How? We create a clone of our database and let it stream the changes from the primary, and then we use it as offloading our read-only queries on top of this, which then leaves the primary database, primary instance for more write-heavy operations. And you can have your heavy reporting queries on these databases, and then let the OLTP load run on the primary instance. All right. Yeah, this solution. I see some smiles here and there when you see index popped up. Yes. Most of the time we take this as our primary solution. I know, guilty as charged, but it's not always the case. And the thing is, what we need to be aware of with indexes, that there is a hidden cost and a silent tax. Yes, they are different. So the whole hidden cost is when you are introducing a new index on a table, what are you expecting? You are expecting your queries to fly. Great, you have it, you're gonna get it. But at what cost? Now the database engine needs to maintain that index as well. That is the hidden cost. Well, we accept that hidden cost because it's now useful, correct? Now one of our queries is flying fast and we are not struggling to provide any results. But then business logic changes, queries changes, and then we keep those indexes on the table. What happens is, over time, these leftover indexes, we don't use them. So that's your tax that you are paying. You're not using anything, but you are still paying to maintain it. And the truth is, the cost you are paying is not always just to maintain it as well. So databases, database engines, they have their mind, the optimizer, we say, which when you send a query, it goes back to the tables, it checks how selective is that query, which index I need to use, how to do these joins, which method I need to use, and it needs to get those answers like within a few milliseconds. And when it's not able to pick the correct indexes, because now we have so much indexes that it's not able to do this calculation effectively, then we find ourselves with this. You see, on the left, there is this reaching out for 34 million records per second for one query. Why? This is a real example of unused indexes and what they cause. And we had this pretty recently. It's a very fresh example for you. You see, when we are looking at the metrics, that we noticed one of our queries are going out of hand. It was running pretty fast, and most of the time it was running fine. But from time to time, you see that it goes out of hand and then comes back down and goes up, down, up, down. And it was causing our alerts to fire. Yeah, CPUs are melting. Someone needs to take a look at it. And what happens when you are burning the CPUs? Yeah, you're making the infra team mad. Because then they need to check what's happening behind the scenes before handing it over to you. Yeah? Then they say, another database making a mess. Let's hop it off to them. Then we are checking it, and then we are also handing it over to the developers. It's your query, let's take care of it. No! Everyone is working so hard with something else, trying to extinguish another fire, someone needs to look at it. Okay, back to the query. Then, while we're looking at these metrics and we say, okay, this query is getting out of hand, but let's look at it, what's happening, which tables it's touching, and how many indexes we have. And then we find one unused index, just with one column. And we show that, okay, this query is actually able to utilize other indexes, pretty good, no issues. And then we said, okay, we're gonna drop this one column unused index. After we dropped it, what you see here is it dropped 10 times from here, actually here, 34 million to 3 million reads per second on an average. So 10 times just for dropping one column index, and the table is even not that big. You see, these kind of things that causes many issues, that is pretty small, but needs to be taken care of over time. All right. For the bonus section, maybe some of you noticed already. I know there are many people with keen eyes that might have spotted some weird issues with the slides, especially with the numbering. Have you noticed that? Anyone? Should I go back? Let's go back quickly. What's happening? Oh my God, this is a mess. Okay, let's go back. Yep. This, what is this? Can someone name what's happening there?
Sequences.
That is sequence. Sequences are great. Auto-incremental updated IDs. Yeah, we all love them. But they have this unfortunate case that they leave gaps. And you can just basically have these kind of issues all over. And also, you might have seen that the numbering also repeats. That is the missing primary key. So I have the sequence in place, yes. Consider this slideshow as a table, and each slide as a row, like as a record. So while I was inserting pages, because I was missing the primary key or a unique index, or some of them also missing the ID, it's between us. And what is happening? Someone else was also inserting something just because they wanted, and they were messing up with this numbering. And what we expect from sequences, we expect sequences to, by default, automatically increment the IDs, give us something new each and every time, make it consistent. That's it. But as you can see, they introduce gaps. When one of your sessions tries to insert something, and then you say, okay, roll it back. What happens to that ID? Poof, it's gone. You already used that because another session already got the next one. So you're not gonna use the old one again. It's gone. If you wanna have something exactly sequential, contrary to its name, you need to develop your own locking mechanism and have a proper locked sequential IDs if you want. For example, if you are having some, I don't know, invoices, for example. So, and don't forget your unique indexes, primary keys, foreign keys, so that you will have this mess, don't have this mess. All right. And the last thing that I would like to touch as a bonus is the triggers. So what's a trigger? I guess we all know we have these kind of things in our applications. Yes, we have, I don't know, some hooks that we use, web hooks that triggers on certain cases when things are met. Similar to those, we have database triggers, and those are running within the same transaction that we send to the database. They are not individually running by itself. Yeah? So the important part here is what I'm trying to say, that triggers introduces additional overhead. They are great. Sometimes we use them to create historical data. Sometimes we use them to update when someone updates the row that we update, for example, the timestamps. We keep additional log with triggers, or we use it to do some other calculation, some crazy stuff behind the scenes, but they are running within the same transaction. And if they fail, your transaction will fail as well. There is that. So, there is that. All right. So, we have covered from the start that we started with the architectural illusions that we all create. This distributed monolith, sometimes we call. We reviewed the core engine. We discussed the protective parameter, and we talked about the indexes, and we need to be like strategical on our approach in that. And if you think about all of these stuff and bring all these to your prompts tomorrow, then your applications will be faster, more reliable, and of course your AI will thank you. So you are guiding it with all these decisions that it doesn't need to make for you. Well, thank you all for your time, and I would like to take any questions if you have. No? Great. I see sleeping. Yes, please.
So you mentioned one thing. When developers try to fight with DBAs, where is the responsibility line, right? So how do you define the boundaries, and what's the process? How do one avoid this fighting? Because everyone thinks that this problem should be solved there.
Okay, so the question is how to overpower developers. No, the question is how we collaborate better, yeah? How we just decide on where our responsibilities start and end. This depends. So here in Colbet we have this separation that DBAs, okay, so there is DBAs and there is SQL developers. So SQL developers' job is to develop SQL queries. So in this approach, DBs only think about the infrastructure, the availability, and so on, and how we, for example, restore, recover from failures. And mostly the SQL developers think about something like the query performance. Here we have developers, they have great knowledge and they do their queries by themselves. And when we have an issue, we always collaborate. Yeah, there is, from time to time, there is some discussions like, you should fix it, I should fix it. No. That's our line, that we always collaborate, and it actually depends on how your company decides on how the departments or teams collaborate each other. Sure.
So imagine that we have one more team who does some analysis, and you change something, performance, structure, whatever. So we have the agreement with developers, so Fisher does more. But you forgot to mention this for analyst team, and then in fact, you have no data at all for some period of time. So how do you operate together with analyst team?
Okay, one moment. So there is something, the question was, we have developers and we have an analytic team, yeah? We have analysts, and developers changing something, and now the analysts don't have any data, correct?
Yeah, because I need to adjust their role.
Yeah. So in our case, we, as I mentioned, we let each team know of the change. We don't do changes just for the sake of change.
But how exactly you do this? I mean, this is a process where everyone should be aware, and we need to ensure, right?
Yes.
Visual information.
Yes. So in our case, we have a separate decision support system. We have our data warehouse or analytical data stored in somewhere else. It is protected from the changes. So when something is changed within the application or the application schemas, then this is automatically reflected by our data warehouse team, for example, to the data warehouse databases. So this is how we keep things moving, again, collaborating. There is one.
Yeah, question about distributed monolith, how complex it could be, and what is a good use case for distributed monolith?
Yeah, distributed monolith is, you see here, why I'm saying it as distributed monolith. It's a mix of both worlds, yes? Because if your application, one of your application is not able to run by its own, so it depends on something else, like someone else's data, basically, and it doesn't own it fully. So we cannot say, at least from my point of view, we cannot say it's just a microservice, because if you just bring down the other one, it's not going to work. Yeah, maybe in our mind we can say yes, it's a microservice for sure, but from a data perspective, it's not able to run by itself. And most of course we are saying this with the acceptance of how complex systems we are designing. We are not, or I am not saying that this one is bad, this one is good, all right? I'm just creating some awareness of how we distribute the data from the data layer perspective. And we need to be aware of these kind of like late updates, network latency, because now when we have this kind of distributed data, now your database joins, it's just a simple database join, now becomes a network problem, because you need to get some data from this database, get some data from that database, and basically you're creating a network traffic and then joining them in somewhere else. So
Effectiveness gets better, but the overall performance usually goes down.
not necessarily, not necessarily overall performance is going down. I mean, we are doing this to gain performance. We are distributing our applications into smaller modules, both from a rapid development perspective, not just because they're looking good in Git repositories, I hope. Yeah, smaller repositories, better looking. No, not just because of that, of course. And with this acceptance of like we are developing complex architectures, we want things to be able to like distribute on different hardwares maybe, or maybe we want to use different modules from time to time. Like, for example, in this case, here. So for example, this application depends on data from this one because now we introduced some ways to push data to its own database. It's not able to run by itself, but we can say that we can cut this application, split it into two, have a better performant one for another simpler job, maybe even using the same database, and use the rest of them for another thing. It's depends on what you are doing, how you are doing. We are not only having performance or data issues and having this. It just depends on what you want to do. So, not just one is good and bad. Yep. Yes, please.
Can you take that side?
Yeah. Sure. Oh, sorry.
I have a broad question. I wonder if you have tried to automate your work with AI agent, and what kind of approach worked or didn't work out?
All right. What's the time? Yeah. Seriously, what's the time? Can I learn?
Almost half past
8:30.
Okay. So last few questions. Let's say I don't want to steal your pizza time as well.
This question and after that.
Yeah. So with AI, I think it's more for a development question, because while we are trying to implement some AI solutions for databases, it's more for reporting, tracking the databases, tracking the metrics and how it behaves, and creating rapid solutions with AI. Not from our point of view, because we don't need to develop something on the back end, but our use case is to have, like for example, have these logs pumped into an AI and get instincts from it, instead of some human reading them, that it will just summarize it and point out, okay, because they are good with text basically, and they immediately capture if something, that this pattern, if it's not good looking, then it will immediately let us know. This kind of approach we are taking, not anything else in our case, because we don't want, we are not the data owners also, so we don't want it to do any crazy thing in the database as well. Thank you. Okay, we have a few more questions. One more? Okay, one more question. Here, sorry, there, he was asking.
This slide is suitable for this question. What's the right moment for this kind of architecture decisions? Exactly migration moment, when the critical mass is some kind in focus. We all know that each engine has its pros and cons, but what's the right moment not to invest into some kind of a bottleneck fixing, trying to optimize the legacy things, but what's the right moment to migrate to a new engine and to deal with data export and following info?
What's the right moment to change your database engine?
Yeah, or at least try
It's now.
to plan.
Yes.
Well, it's a very complex question, and it has a very complex answer. It depends. I cannot say like this. We need to think about all the cases that you are having issues. Are you having some issues with write heavy queries or reads, or are you having some issues scaling or replication, or you want to have sharding and multi geographical expansion you want. What's the case there? Then we can talk about, and okay, it's good to have this engine for sharding or that engine for writes, for example. It depends. Sorry for that, but all right. There is no question. Sorry. There are two things I haven't touched on purpose. One is visibility, that you need to know what's going on within the databases, your metrics, and your logs. Second one, that we had a few questions like what's the friction between developers and DBAs? Is it security? We want to secure it, you want to destroy the security. So keep your databases secure, your users secure, your data secure, and yourself as well. Thank you very much.